So I've looked at XCM in the abstract. Pretty familiar with what it does now, and we've looked at like one or two programs. So let's look at something a little bit more complicated. Hopefully it'll make sense. Okay, so this is an example of a cross-chain use case. Specific use case we're going to look at is a DEX, and it's a good example of using XCM without having to fall back on primitives that you shouldn't really be needing, like account IDs. Right? Account ID is not something that you really need. Something for like storing, indexing and storing information on a chain. It's not something you should be really needing if you're just wanting to do an operation on another chain that's transient, ephemeral, right? We're also going to look at one or two of the things that we need to do in order to make this, in order to make the interoperation secure, given that the service doesn't necessarily trust who's going to be using it. Yeah. So if it's a DEX service, you really want to have as many users as possible. You don't have to force each one to be like kind of trustworthy. Yeah. So you have to make sure that, for example, fees are charged. Yeah. Okay. So yes, by the end of this, you should be able to start thinking about building cross-chain use cases, think about the things that are involved when you're designing them, architecting them, understand what services there might be pre-existing in the ecosystem, and probably most importantly, should have an idea about the risks of cross-chain interactions and how to manage those risks. Cross-chain DEX, right? Familiar with what an exchange is? That X part, right? I've got one asset, I want something else in exchange for it. DEX, decentralized, which kind of goes without saying. If it's going to be sitting on a chain, I mean, technically it could be a permission chain, so it could technically be just a blockchain shim for a centralized exchange, I suppose. Doesn't technically need to be a DEX, but probably will be. So let's have a look. A cross-chain exchange. What do we want to specifically do? Well, accounts on other chains should be able to transfer tokens, do an exchange without an account. Yeah, just do the exchange because they don't want to like have to deposit stuff into an account specifically. They want to do the exchange and get their tokens out, right? Maybe also add or remove liquidity. This third one is a little bit trickier, but the first two we're going to work our way through. Good. So very simple. We've got some account sitting on some chain. We're going to transfer some tokens over to the exchange chain. And we're going to do a swap and then transfer some tokens back again. Although we don't have an arrowhead going in the other direction, that is actually what we're going to do. Now, of course, if we have a user here, they could just deposit the tokens directly into an account on the DEX. For now, we're going to assume that that is not, it's not what they want to do, and it's not what they maybe even can do, right? Might be that the this A here is a logical entity, like for example, a governance body. Yeah. This indeed is already happening in the real world with a governance body sitting where A sits, and a real DEX over on the other side. And this is where XCM like matters. Yeah, if A is a logical entity, not specifically a key pair, then you don't have the option of just having a key pair over here and interacting with the DEX directly. If you can interact with the chain directly, it's usually better to do that. Yeah, because occasionally someone will come to me with like an XCM architect design, like a design of using XCM, where it's like, well, they're going to go through this chain, and then that's going to send an XCM over here, and it's going to do something, and then that's going to send an XCM back over here, and then the chain's going to tell them that it's done. And it's like, well, why are you using XCM? Just have them interact over here directly. Yeah. XCM is slow and expensive. Like it's what you need to do if the interaction is between two trustless logical entities. It's not what you need to do if you know you have a human sitting behind. You know you control the UI. Right? UI can just send the transaction straight over there. Could even send an XCM. If you really want to use XCM, it can just use execute XCM over here. Yeah. There's no great need to go in here and use send XCM and use the message passing stuff and go through 4 different message queues and calculate however many fees. Like it's way, yeah. Take the simpler route. Yeah. All right, let's move on. So we're going to very quickly touch on configure XCM. We're going to cover this much more in a later, I think maybe even the next module, but we're going to talk about it a little bit here. So before your chain can use XCM, you have to tell it how to use XCM. Particularly, you have to tell it things like, how does it get to some other location, some other chain? Yeah, that it doesn't know automatically. You have to tell it how to interact with your pallets. It doesn't know automatically. The pallets, generally speaking, are not XCM aware. Yeah. They don't understand what XCM is. They provide like the balances palette, or the assets palette, which you might already have seen, or the NFTs palette, uniques palette. None of these understand what XCM is. They just provide asset facilities. So in order to have XCM interact with them, we need to configure XCM to understand that these palettes exist and that they map on to particular asset identifiers. Yeah. And that because, of course, these palettes work through account ID. Yeah, they store things under account names, 32-byte identifiers, generally either a public key or some sort of hash. We need to make sure that XCM or our XCVM instance knows how to convert a location, which is what it understands, into one of these account IDs. Now, I've talked about this a little bit before. That's the sovereign account thing. It's a conversion. It's just a very simple converter function that takes in a location and hands out an account ID. Yeah, very simple. But this is exactly the sort of thing that we need to think about configuring in order to make our XCVM instance work with our specific chain. So the first thing that we're going to do is this little magic type asset transactor. Now, what an asset transactor is able to do, so that's just the name of the type. What a fungibles adapter is allowed to do, it's, as you might guess from its name, it's an adapter, right? So it takes one particular type, in this case, the assets palette, and it converts it, translates it into another type, which is a something that XCM can use directly. Yeah, something that XCM understands, or the XCVM understands directly. Why can't the XCVM understand the assets part directly? Well, because it's a very opinionated, specific palette. We don't want to like pollute the XCVM interface by designing it around one particular palette, because maybe some of you guys want to make your own palette that handles assets in a particular way. Better, therefore, that the XCVM asset interface is as simple and pure as possible, and then we just use an adapter. The adapter is very simple, as you'll see. So we hand it the assets palette. This is an instance of a palette. Then it needs to know a couple of other things. It needs to know the a matcher, which is basically, I have this asset ID. Do you know what it is? That's basically, it's the answerer for that question. Yeah. Because of course the XCVM deals in asset IDs. Well, when it has some operation to do, like you withdraw asset or deposit asset, it needs to know if it should use this thing. And therefore it says, I have this asset ID. Do you know anything about it? And if it goes through all of these, if its asset transactors don't know anything about it, then of course it says operation failed. Like you're trying to transact on an asset that I know nothing about. But you know, if it's designed properly, if the program is designed properly, then it should match something. So it needs a matcher, which is basically us mapping asset IDs into specific types of assets. Now, if our asset type in our assets palette happens to be a location, happens to be exactly the same thing as the asset ID, then of course this can just be an identity thing. Yeah, it can just be like, does assets contain an ID, which is whatever location and what asset ID I'm being asked. But a lot of the time, assets will be something that's more on-chain native, like I don't know, U32 or I don't know, whatever it is that you use to identify an asset. So the matcher will probably do something to like decode the XCM asset ID and like compare it to what assets it has in the assets palette. And finally, well, I guess there's a few extra, but I think these are like largely unimportant. Finally, we have the location asset ID. This is exactly the thing that I've been talking about before, the sovereign account. It just takes a location, gives you an asset ID, right? And since all of the data types in assets palette are really just the asset ID and an account ID, yeah, then these two cover everything. These two just provide you a way of converting from the language of XCM or the XCVM to the language of your on-chain palettes. In fact, this will work with any palette that implements the fungibles interface. And there is a similar one that's a non-fungibles adapter, and that will work with any palette that implements the non-fungibles interface. Yeah. So you've got a full set. The XCM builder crate gives you most of the adapters you're likely to need. Yeah, but that's something that we're going to look at a little bit later as well. Good. Now, we've covered this a little bit in the past, whether we're going to use teleports or reserve asset transfers. This, of course, depends on the trust relationship that we have with our destination. If we don't trust them for this particular asset, then, and they don't trust us, then we're probably going to use a reserve, a third-party reserve, and choose the third party that doesn't introduce more trust relationships, and therefore use probably the issuing chain or possibly something like Asset Hub. Otherwise, we can get away with the teleportation and avoid that extra hop and clear origin and all of the headache that brings. Good. But let's assume for now we're going to deal with reserve assets, because that is the usual thing. It's actually quite rare to be dealing with teleportation at this stage, because it's rare for two parachains to actually have that like 100% trust relationship. Yeah, it does happen occasionally. Asset hub and bridge hub, for example, a teleportation. Okay. So reserve asset transfer. Let's look at our provisional code. This is our program. We will assume for now we are on the reserve chain, right? So we will assume for now we're dealing with an asset that we issue ourselves. So maybe we are Moonbeam. We're on the Moonbeam chain. We want to exchange some Glimmer for something else. Well, we are trusted to be that reserve, which means we can withdraw it from an account and then use this deposit reserve asset. What deposit reserve asset does, it's exactly the same as deposit asset, which means take something out of the holding register, put it into an account ID, with one difference. This reserve in the middle means that we also send a notification on to that destination, to the location that matches the account ID we're putting the asset in, and we tell it to do something with it, because it is our expectation that they will trust us as a reserve for this asset, and they will issue the wrapped version, right? This one-to-one derivative. Yep. That's a very important thing to understand. Difference between deposit asset, which just, you know, you deposit asset, you give it some assets in a location or destination, right? And it will just put the assets, take them out of the holding register. In this case, it's just everything in the holding register, and put them in this location, or rather the sovereign account ID of this location, right? That uses that converter that I showed you just before that converts a location into an account ID. Yeah. Well, deposit asset just takes those two. You don't get this bit. Yeah. Clear? Yeah. Take an account, take some assets out of the holding register, put them in the account ID associated with some location. Clear? Yeah, nodding. Good. Deposit reserve asset does exactly the same thing. Take some assets out of the holding register, put them in an account ID controlled by some location, associated with some location, and controlled by that location. And then send a message onwards to the location, instructing it to do stuff with a presumably now issued derivative asset. Yep. Good. All right. Okay, what are we doing here? Well, very simple. We're withdrawing the asset, depositing it in some into the sovereign account of this parachain, the DEX Power ID parachain, which is sibling because we're going up a step first to our parent, to our shared parent, and then down into the parachain, and then we're having ourselves issue, send a message onwards to this parachain, saying, right, great. Once you've issued me the derivative, what I want you to do is deposit the asset into some beneficiary account on your chain. Now, this isn't doing what it is that we want to do, right? This is the first step. This is just to show you simple way of basically, if you're on the reserve chain, getting one of these wrapped assets out of the chain and onto a destination chain, right? Good. So yes, back to this concept of a sovereign account. A is sending some XCM to the DEX. Now, what does the DEX see? Well, the actual origin that it sees is this funny thing, /parachain A /account ID 32 with whatever account ID it is. If it is indeed an account ID 32 that is sending it. Now you might wonder, well, hold on. It's only parachains that send XCMs. Account IDs can't send XCMs, can they? They don't have their own message queue. Now, you'd be right, they don't. In fact, what happens is, when you send from an account ID 32, you use the XCM palette to do this, which you can, the entire XCM program is prepended with a descend junction instruction. Yeah. So what happens is, before anything can happen, that you can decide at least, it takes the origin and it just pops this account ID 32 junction on the end of it. Yeah, so it's like whatever origin you think the message is coming from, well, actually, it's coming from this account ID 32 under that. Yeah, and that allows us to effectively limit, because what's the difference between having this origin be a parachain A versus parachain A / account ID 32? Well, this one doesn't have access to all of the other people's stuff on parachain A, right? It's a lot more, I mean, it's doing the right thing. It's quote unquote more secure. I mean, it's actually secure as opposed to totally insecure, where if this guy chose the right code, he could just empty everyone's accounts. Yep. So it's pretty important that we do this. And that's how it works. We don't actually have many different XCMP channels, one for every account ID. That would be really crazy. That would be way too many message queues and things. So rather, we just use the same channel, but when it arrives at the destination, the code that actually executes first prepends something onto the origin. Yep.
This sounds important. So can you quickly explain again, like, the direction of what's going on here? And because yesterday you were talking about the drop origin. Drop origin, was it, right? Or
the drop? Clear origin.
Clear
yes.
origin, yeah.
Yeah.
And you were mentioning the descend as a possible alternative.
Yeah, that's right.
So can you just like briefly explain again the scenario here?
Sure. I mean, what this comes down to is when the XCVM is executing, it has a privilege system, right? Everything that many of the instructions execute on the basis that they have been ordered by someone or something. Yeah. Some of them don't. Some of them just do stuff with the other registers, like the holding register. They manipulate assets or whatever. But many of them base their actions upon where the instruction is coming from. And we call where the instruction is coming from the origin. Yeah. Now, given that you can author XCM to do whatever you want, even as a user, if you want to, you can notionally kind of drop down and just make a message and execute it. And of course, the chain doesn't know the difference between your UI and the user. Yeah, so it has to be secure in both circumstances. Then what we need to do is ensure that if it is the user that is executing an operation and not your chain, that there is an origin that is commensurate with the user's privileges. Now, we're familiar with the idea of an origin which is your chain. In this case, actually, it's not. Anyway, the chain A, right? We're familiar with this idea because chains are connected with XCMP. Oh, yeah, okay, yeah. And if a message comes from another chain, then it has that origin. Oh, okay, yeah, right? But what if it comes from a user on that chain? Well, we're not going to have a ton of different XCMP channels, because that would be like one for every user. That wouldn't scale at all. So what we need to do, and a very easy workaround, is just to modify the origin once it arrives by prepending an instruction that changes the origin. Now, one of the ways we can change the origin, as we discussed yesterday, is the clear origin instruction. And this just wipes the origin out, right? There is no privileges associated with the sender now. But this isn't, this is like not that useful because it means we can't deposit an asset. Well, we can deposit it. We can't kind of withdraw an asset, and there is no concept of any singular kind of privilege, right? Any account that we would control. If we still want to have an account that is associated with us, then we need to have some sort of origin. But it definitely shouldn't be the parachain's origin, right?
Because that would have too much authority.
Indeed, that would speak for the parachain, and indeed, the parachain only wants us to be able to speak for ourselves on the parachain.
But it is the responsibility of the sender to add those restrictions, right? And it's the responsibility of the sender of the message to add those restrictions, like to say.
The sender of the message to add the restrictions. Well, the sender of the message is never going to restrict themselves. They can never be trusted to restrict themselves. Like either they are restricted by the system, or it's insecure.
Yeah, true. Correct. I'm just trying to understand like the mechanism under which this restriction is added in, like the origin.
So if we allowed this to happen without the descend origin, then the origin would be a parachain A. Now, if parachain A happened to be storing, say, I don't know, some assets for its own governance on there, like its treasury, and it just happened to have an account with that in on the DEX for whatever reason, and the user, some user guy sends a DEX, is allowed to send a DEX message over, well, of course, they just change their DEX message. They wipe out the bit that does any exchanging, and they just do a withdrawal. And because they're operating with the parachain A origin, their withdraw would be able to withdraw basically any other users of parachain A's funds on the DEX chain.
Okay, so is it like the deposit reserve asset? Like if we go to the back last slide, is it in there that this restriction is?
Exactly that.
Okay, that's
okay, so
like the descend origin is derived from this struct, or
let me think. Withdraw asset. So our
withdraw or deposit. I guess it's like the asset generally.
Yes. So when this message gets sent, in fact, there is a clear origin afterwards.
Okay.
So what happens is, sorry, not afterwards, before. So what happens is, this message, this action, that's actually kind of what it's called, I think, an action or an effect, right? This doesn't happen in isolation. It can't, because there aren't any assets for it to deposit if it were a message just sent in isolation. So first, the first part of the message creates those assets, right? And the way that the assets are created is that our reserve chain that we're on sends a message saying, make some wrapped assets. Why would it bother doing that? Well, because it's the reserve chain and it trusts it. If it says make some wrapped assets, it trusts it that it's not lying. It trusts it that some assets have landed in their sovereign account, and it's notifying them, and would you please make some wrapped assets commensurate with the assets that have landed in your sovereign account, right? That's why. Now the user is allowed to decide what this code is. Yeah, in general. It's because we don't know who is executing deposit reserve asset. So this code has to work even if it's not necessarily us, the chain, who are or the dev who are deciding what it is. Deposit reserve asset must work. And so what happens is deposit reserve asset, it does this first instruction, which is mint some wrapped assets, please. Okay, fine. Then it says, what's coming up next is code that I don't necessarily trust, because maybe the user is using deposit reserve asset. Some user somewhere. So what I want you to do is wipe out my origin, because it's not me speaking anymore. It might not be me speaking anymore.
Chain.
That's me as the reserve chain speaking to the DEX chain.
Yeah.
In this case, it's fine because we're the one who decides, and we obviously are not going to do anything that we don't want to happen. But the problem is that this is an instruction, and anyone can call it.
Yeah.
So it has to be made secure by default.
Yeah.
And so securing it by default basically just means doing the thing that you know is safe, which is, hey, I've received some assets. You should mint some wrapped assets, and then clearing the origin.
Okay.
What comes next is not necessarily me,
Okay.
Like
but that's clearing origin.
That's clearing origin. Now the send origin has a similar effect, but rather than clearing the origin, it says it's not quite me. Yeah. It's this guy on me.
Yeah.
Yeah.
But that's happening in the deposit asset.
This actually is doesn't happen
question.
Here. But if we wanted it to happen as parachain A, we would use descend origin. So this specific schematic doesn't directly apply to the previous code.
It's just because yesterday you were showing us like a similar kind of Rust code snippet, and there was like this XCM macro. In it had a clear.
Yeah, apologies for the confusion. So this refers to what we might want to be doing, which is if we have an account, if we have some user on A who has some account ID, we may, when the instruction arrives at the DEX, wish to have the origin, which is that user account, on A.
Yeah.
We obviously don't want it to be A itself, because that would then be everybody's account. And if the user is able to control what this origin does, then we don't want them to be able to control the same stuff that everyone else can control. But we may want them to have some sort of origin so that they can do things like deposit into an account and withdraw at some point later. And so that allows that to happen.
Thank you.
Okay, so let's look at one example of a location to account ID conversion. Now, as it happens, there are tools for, you don't have to write this function yourself. You can piece together building blocks. Now, the first thing that we do is we say, well, if it's just an account ID 32, like if our location is an account ID 32 and nothing more, so we're not going to some other chain's account ID 32, it's just our account ID 32, then we alias it into that straight account ID. Yeah, we just equate them. If I'm account ID, if the location is sort of /account ID 32 X, then we say that that maps onto X. Yeah, everything else will be different, but that specific thing it doesn't make sense to change what account ID that is, because it's the account ID on this chain. So it makes sense that it would be the account ID on this chain. That seems pretty self-explanatory. Now, for all of the other locations, we don't necessarily want to, like, we have to be a bit careful now, because we've said, right, those account IDs that are on our chain, they map to the account ID on our chain. It's self-explanatory. So for all of the other locations, we kind of want them to map onto another account ID. Yeah. Now there are arguments to say, well, actually, what I want is for this other location to map onto this person's account ID on the chain, like, so that essentially the same account would be controllable by two different locations. This is questionable. There's arguments for it, mostly convenience. The arguments against are of security. If you have two different XCM endpoints, not to mention a local endpoint that can control the same account ID, then confusion can occur because someone says, well, hold on, stuff's been transferred, but I didn't do it. It's like, oh yeah, that's because some other logic that was happening elsewhere sent an XCM which withdrew funds. Yeah. And of course, if for whatever reason they stop using that logic, they use the local key to do it, and then there's some issue with that service, and or there's something that they forgot about, and it started running again and started withdrawing accounts. This can be a significant cause of stress, at least for the user. Not to mention the possibility that if you now have two different things with different security credentials controlling the same on-chain entity, that entity is now the lower of the two security levels, right? Now, given XCM is such a low-level tool set, I would say you've got to be very careful before you start trading off security for convenience. But be aware, it's possible to do if that is the decision of the chain. So this, as I say, allows you to map locations to account IDs in any way you choose, and it's pluggable. So you've got, in this case, we have this hashed description adapter thing. You can ignore the account ID, but the describe family essentially just says, give me a standardized human readable version of the location or the locations that would fit in this type. And then hash description takes that and hashes it, and that hash is the account ID. So essentially it says, describe the location to me in a way that isn't going to change with forthcoming XCM releases. So it's going to be stable. And then give me an account ID 32 based on that. Yeah. In this case, we were just describing things that terminate. Actually, we're just describing account ID 32s. We probably want to this may be, I'll have to check the code. That might be wrong. It might be that we need to, no, describe family. Yes. So describe family understands how another, how some tail of location is related to us. How might a location be related to us? Well, it might be on us, it might be our parent, it might be our sibling, it might be our child, right? And describe family understands this. So basically it understands ... and ... parachain and parachain, more or less, yeah? This bit, it doesn't understand anything that follows that, which is why this has terminal, right? This is like the end of the location. And what this does is it understands anything that ends with account ID 32. So together, they understand ... account ID 32, ... / parachain / account ID 32, and parachain / account ID 32. Yep. That's basically what locations this will understand. Yep.
Yeah, so then describe family is the thing that prevents us from having like the same account ID for multiple XCM messages that want to access that location, like from different parachains.
Yeah, it's describe family itself gives you a different description depending on both the account ID and its its relation to you, the chain that it's on's relation to you.
Okay. So if, for example, two different parachains wanted to access an account ID on a third one, wouldn't they get the same described family because the location relative to them would be the same?
Yeah, so this is a questionable decision to allow two different parachains to access the same account. Normally, every logical entity would have only one account, would have a unique account mapped to it. Mapping the same account to two different logical entities then means that both of them, it's kind of like handing the same private key to two different people. Yeah, you wouldn't do that normally. You would say, well, you each have your own private key, but what we can do is maybe give you a one of two multisig that you can control. Yeah, and this is much more secure because then you're not sharing keys. And then in this case, we're not sharing keys exactly, but we are creating a direct link to the same account. It's like we're hardwiring them to be the same thing. We can never remove that in the same way that you can never remove a secret key from someone. They can never remove. Once you have, if you had a described family that basically said, if you got rid of described family and said, doesn't matter what the family is, just look at the last account ID 32, and that's what should be their account ID 32. You could have some random chain that comes along, and it pretends that it pretends to be an account on itself, and then it would be able to execute code on this chain with the same permissions as, like Moonbeam's account, or Akala's account, and it would be able to empty any of those assets. And it's just not very secure. Now you could say, well, I'm going to filter which chains are allowed to do this separately. Well, you would really need to be very careful about that. And then you would still have the issue that if Moonbeam got compromised, it could empty all the assets from Akala. Yeah?
Yeah. Okay, so, and then how would you avoid doing that?
How do you avoid doing that? Well, this avoids that happening.
Oh, okay.
So first we actually do describe the family, which means if it's /moonbeam/gav, it will describe the /moonbeam as saying my sibling chain Moonbeam, and then the account ID 32. So my sibling chain Moonbeam Gav's account on my sibling chain Moonbeam. If then Akala came in, it would be my Gav's account on my sibling chain Akala. And then if some dodgy chain came in, it would be Gav's account on my sibling chain Dodgy. And they would each get hashed, and they would each have 3 different hashes, and therefore 3 different account IDs. If you disregarded the family and had them all on the same account ID, then you'd end up with Gav's account, and Gav's account. Yeah, and then sure, for Akala and Moonbeam it might be fine. They might not screw you, but Dodgy chain could then just empty all of all of the assets stored on behalf of users of all of the parachains, because a Dodgy chain can pretend to be any user at once in its chain. And if you map all of those users to all the users of Moonbeam and Akala, then it can steal all of the assets of those users on this chain. Yeah.
Yeah. Thank you.
So it's always be very careful when considering origins. Origin is basically privilege. Yeah. And if you combine privilege, if you map privilege to be in the same across many different things, and you do so very widely and broadly, you risk nefarious actors coming along, pretending to be, I mean, in this case, the pretense is minimal because they're called dodgy chain, but you know, in principle, you could have like low security chains that just want to use your DEX, join in, and then they get a governance attack, and then they wipe out all of the other users' balances on your chain. So you've got to be super, super careful with this stuff. In general, play it simple, keep everything boxed, right? Pigeonholed. XCM can protect you, like the Substrate's XCM stuff can protect you, but you have to use it to protect you. If you combine everything into a big box, then you're going to be at a big risk. All right. So swaps. There is an instruction as it happens. Exchange asset. Pretty handy. Do you have a question?
To the previous slide.
Oh.
Yeah, I was wondering, how do you differentiate that Moonbeam and Akala are different? Because, so I'm guessing it might be like parachain index.
Mhm.
But if you do that, I mean, I think there is a way to swap indexes for parachain, right?
Yeah, every parachain has an index. Yeah.
Yeah, but you there is a way to swap also, right? The index.
Oh,
in
I see what you
Crowdload.
mean. There is, though. Yeah, sure, there is.
Would that lead to?
Yes, it would.
Okay, well.
Don't swap your parachain indices. If you do, you're going to have to appeal to all the people using Describe family, and that your users have funds on that you're interacting with, to please describe your parachain in the same way they describe your new parachain index in the same way they describe the old one. Now, in general, parachain IDs don't change. Like, this is very, very. I don't know if it's even happened once, but if it has, I don't know the details. They're long-lived identities. Yeah, they're not something that changes. For example, if you get a new slot auction or something, the slot notionally might change, but the ID remains the same, moves with you. But sure, if you know something totally crazy happens, maybe your chain forks or something. It would have to be totally crazy. Maybe there's like a big governance battle, and one chain goes off in one way, and then someone wants to take the chain in another direction, and they win another slot auction or pay for more core time or whatever, and then they take a fork of it, and then they get a new para ID. Then, of course, yes, this stuff would describe the old para ID that maybe is still going, and you would have to. But this kind of makes sense because the assets only exist once. Yeah, like you wouldn't want two things to be in control of the same assets, especially not two competing things to be in control of the same assets. All right, so swaps. Yep, we've got an instruction exchange asset. It's fairly simple. We've got give and want, right? So give is what you're gonna give from the holding account. This is a purely holding account instruction, right? This doesn't need or care about the origin. And this is the beauty. The more of these, origin is only used when we're interacting with on-chain state. Yeah, it's not used otherwise. If we're only interacting with registers, then we don't need to be considering origin. This instruction doesn't consider origin, doesn't need to. So give is what we give out of the holding register. Want is what we would like back into the holding register. And then maximal is basically, do we want to give the all of give to get as much, at least, want back? Or if it's false, do we just want what we want and no more, and we want to give as low as possible, as little as possible. And that's it. And then it's up to your chain, as the DEX chain, to implement exchange asset via a trace interface. So from the point of view of the XCM coder, what do? Well, we withdraw the asset. This is if we are on the DEX chain already. So if we're executing some XCM on the DEX chain, we would withdraw the asset from our account on the DEX chain, buy some execution, right? Because we have to pay to be executed. Hold on, sorry, no. This is annoying. Right, okay. Buy some execution to do the exchange, to execute our program. Do the exchange and then deposit what we get into some beneficiary account, which presumably is an account that we control, unless we want to pay a bill directly on the DEX chain somehow. But... All right. So what if, now I mentioned yesterday, by execution, what it does basically is it burns this from the holding account. Sorry, from the holding register. It burns fees from the holding register. It doesn't do anything else. If you look at how it's implemented, that's all it does. So, and I said there was a piece missing. Well, this is the piece. If by execution only burns fees from the holding register, why do we bother putting it in at all? What if we just sent a ton of programs with just withdraw asset, deposit asset? And if we assume beneficiary is ourselves, this obviously takes time to execute because we're faffing around with the state. But yet no fees are being paid. Yeah, and if we just sent a ton of these messages, we'd end up basically DOSing the chain. Yeah, it's a problem. So we need some way of ensuring that by execution is actually in the message. Yeah. We have a type in our XCVM configuration called barrier. Now, barrier is a condition that must be met for any XCM that we receive to be executed. That's what barrier does. It basically blocks anything that we decide is not, that doesn't fulfill our condition of being worth the time to execute, being worth that effort. Because it's effort, right? It's effort. It is the barrier that looks for that by execution instruction. And if it's not there, then even before anything starts executing, it says, no, hey, this guy isn't paying for their execution, right? We're looking for them to be burning fees from the holding account. If they don't burn fees, we don't even let them start executing. And it turns out that we have this rather convenient type called allow top level paid execution from, and then you can say who gets to do it from. In this case, everything. Anyone who pays for their execution, they get to get past the barrier and actually have their program execute. Now, actually what this does, if I'm being very, very semantically precise, is anyone who sends a message that looks like it will buy its execution. We don't know that it will definitely happen until we actually execute the message, right? Because maybe something fails on the way. Yeah, maybe assets are withdrawn. Well, okay, maybe assets are not even withdrawn. Yeah, maybe it looks as though it's going to withdraw some assets and buy execution with them. Maybe it withdraws assets, it deposits assets, and then it buys execution, and then there are no assets to buy execution with now. And then it fails, but there's an error handler, and it just ends. That would still be a problem, because it would never have actually paid for the execution. So this is pretty restrictive. It does two things to save itself. First thing is, By execution has to be at the top. It has to be immediately after something that could fill the holding register with enough funds. So it looks for one of 4 instructions that fills the holding register: claim assets, withdraw assets, note teleported assets, and note reserve deposited assets, right? So it's each of these 4 things can fill the holding register from nothing, yeah, by virtue of the origin only. So first it looks for one of those, and then it's actually before it looks for one of those, it looks for any origin mutating instructions, descend origin. There's a few other things that it will look for, and it will allow those to be in there because they're very cheap to execute. Then it looks for this asset withdrawal thing, something that's going to fill the holding register from merely on the basis of the origin. And then finally, it looks for by execution. And if by execution doesn't appear in that spot, this fails. Yeah. So basically, it's looking to make sure that some assets get burnt before anything useful happens. Yeah. Now, what happens if something fails on the way? Maybe we attempt to, I don't know, set the origin to something that we're not allowed to. Maybe there just isn't assets in an account and withdraw asset fails. Well, in that case, we've done a little bit of work and we didn't manage to get paid. It's like, well, they've probably still paid for the message delivery, so it's probably not that we didn't do very much work, and they definitely paid a little bit, so it's probably fine. Furthermore, there's not much better that we can do. Once a datagram comes in, we have to do some work to evaluate whether we want to do any more work. So there is strictly a minimum amount of free work that we have to do anything. And this is more or less what that minimal amount of work is, that we basically give for free on the basis that they've taken the effort to send something to us. But we only do that strict minimum before we insist on getting paid, or for something else being true. And there are other barriers. This is a very simple barrier. This is just your basic, I need to get paid to do work barrier. There are others. For example, query response. If the message is just a query response, again, possibly with some origin mutating instructions above it, well, it's a query response that we recognize, that is something that we've asked to be notified about. I mean, then we're going to want to execute it, right? It's for our good to execute it. We're not going to need them to pay us to tell us what our own query was. Like, hey, tell me what the balance is. Sure, can I pay you to listen to the answer? No, that's nonsense. So there are other barriers that say, hey, if it's a query response and it's not doing anything else, and it's a response to a query that I recognize, then that can execute as well. Yeah. There are a few others. Version subscription. Hey, if I've got a channel open with this guy and they're asking to know what version I'm on, then I'll totally allow that to happen as well, for free. Yeah, because I want them to know what version I'm on, so they can send me messages that make sense to me. Yeah, and there's a few others of these.
Like the knowing which version actually doesn't access the states. It's like the runtime. It's defined in the runtime, right? Or
knowing the version of XCM
yeah,
that I'm on.
yeah. So that's not like.
Oh, I see what you mean. Yeah, it's in the code, so it's like you don't need to actually read anything.
And the version you were just talking about, like in the context of like you don't need to spend fees on asking what version I am. So
yes,
we're talking about XCM version.
Yes.
Okay.
Yeah.
Cool.
Hi,
Hey.
I had a question. So you just mentioned like there's a little bit of free work that's done, and then like maybe if some fees were paid for the message to be sent, then it might be okay. Is it like an assumption that some fees were paid? Because could a malicious actor like have some mechanism? I guess this would be like a parachain where they could send free like messages in some way where a fee isn't paid. So is there like a way to have like a threshold of how much free work is being done from a specific origin or location and like kind of cut them off, or like is that not a concern?
Yeah, it's a fair point. There isn't at the moment, but it wouldn't be a bad plan for there to be a sanity limit on how much a particular physical origin could send without those fees being paid. Of course, it's not always so easy to. You may end up with the DOS happening in the reverse in that case. Someone, like for example, someone on Moonbeam might just initiate loads and loads and loads and loads and loads of failing XCM messages being sent from Moonbeam on their behalf. So like descend origin account ID first. So it's like not Moonbeam that's sending the things, but some smart contract on Moonbeam that's sending it. And they might do that specifically to block others on Moonbeam from being able to send messages. Yeah, because then maybe if they're sending it to, like, I don't know, a Carla or something, and then a Carla says, Moonbeam's sending us loads of messages that are just failing. We're going to block Moonbeam for an hour. Then, if there's some stuff that needs to happen within the hour, it's kind of like a big problem. So there are trade-offs. It's usually fine because sending a message isn't free. Like usually the XCMP transport, there is some cost attached, and the amount of work done, if this barrier looks like it will go through and then doesn't, is really very, very minimal. It's basically one database lookup. There's not much else. So, and this is the same is true for transactions. Someone can send tons of transactions that require the block builder to evaluate whether the account has funds in or not, and then the transaction fails, the block builder doesn't get paid. I mean, they don't get paid for evaluating the transaction, yeah, because they never makes it into the block for fees to be paid on it, and so it's still kind of the same problem. Block builders can get DOSed in that regard, in the same way chains can get DOSed here. At the end of the day, we're a little bit optimistic. When we receive any kind of utterance or information or data, we're a little bit optimistic that we can do something with it. And of course, the trick is to work out whether you really can do something, whether it's really in your interest to be listening as quickly and cheaply as possible. And the same is true in real life. When you meet someone new and they start talking to you, constantly going through, like, is it worth me having a conversation with this person, or are they just talking total bullshit? Yeah, and people that can work this out very quickly generally have much more interesting conversations than those, much more enlightening, much more rewarding conversations than those who don't.
Thank you.
Alrighty.
Another question.
Oh, yep.
I was playing around with barriers a while back, and there's like a few ones, like I think like total weight credit, and then one of them that I was looking into was allowed unpaid execution from everything, and I was just trying to wrap my head around the use case for that. So it seemed to me like perhaps that particular barrier only makes sense when you have like a trusted network or quote unquote federated networks. So I wanted to inquire more on that.
Yeah, so allow unpaid execution from is indeed a barrier, and as you'd imagine, this is basically just if the origin matches this filter in here, let it through. Don't care anymore. Why would we have this? Well, we definitely wouldn't put everything in there, because as you say, it would mean that we trust everybody, every possible actor on a network. Can't imagine many networks where we would do that in a trust-free ecosystem. But it can be useful where we have constellations of chains that do trust each other. For example, the asset hub, the bridge hub, the collectives chain, and the relay chain all trust each other. So they actually do allow unpaid execution from, and then the system chains and the relay chain.
And one quick follow-up, and I was looking into this because a lot of folks were talking about, real-world assets and federated chains, and I just wanted to get a bit of an insight. Is there anything going to guess towards having a world where there's perhaps federated chains or perhaps quote-unquote federated relay chains that communicate to the public version of Polkadot, or is there any kind of worldview on that?
Sure. Yeah. I mean, it's not a world that I've done much thought about, but yeah, it for sure can exist. And I think, as we see more centralized organizations looking into the blockchain world and wondering if they can interact with it in some way that makes sense for them and their various, legal situation, we might see more and more of this, where, for example, you could imagine some barriers that say, I don't want anything to be able to execute unless it comes from a whitelisted account or a whitelisted parent, a whitelisted account, or a whitelisted parachain. Yeah, and then they start whitelisting particular parachains that, from their point of view, do whatever is necessary that frees them from enough legal liability.
Got it. Thank you very much.
Alrighty, on we go. So up until now, let's have a look at our code. So we were drawing an asset on our reserve chain, right? We control the reserves, right? So maybe we are a Kala and we're doing Akar token or whatever, we're Moonbeam, we're doing Glimmer token or whatever. So we are the reserve chain for this asset. So we're drawing it from an account, we're depositing, we're telling ourselves, like this is sort of a user on the chain, right? We're telling the chain, hey, please deposit this asset, deposit reserve asset. Here are the assets. I want to deposit everything in the holding account into this person's, organization's, on-chain entities account. And notice here that we are identifying an account in exactly the same way we are identifying a chain. Yeah? This is what our location to account ID magic or converter does. But it's very useful because we're depositing assets into an account and we're sending a message to that same identifier. Yeah, we're using this identifier, this kind of consensus URI, for two different things. One of them is to identify where the assets are held on our chain, and the other one is to identify who we need to notify that they now have assets. Yeah, and those two things are associated. There's a strong association between them. The kind of point of association is this location here. Yeah. So dest means two, it's actually two destinations. It's the destination of the notification message, and it's the destination account ID that the funds are being put into. Yeah, it's a multi-use dest. And then this is the bit of code that we want to execute, knowing that it will be executed on the DEX chain and after the holding account has these wrapped assets in it. The one thing we don't get is to have a useful origin. Yeah, yet. But as I said before, at the moment, this executes with a clear origin stuck before it, so the origin is none. Probably in the not too distant future, maybe XCM 5, the next major revision, we will switch that out for a descend origin. So it descends into whatever local origin this is running with. So if this probably is running with an account ID 32 local origin, then we will then descend into that origin here. So it will now be running with a / our reserve parachain / account ID 32 origin from the point of view of the DEX chain. Yeah. Now, this still isn't that useful. Let's think this through a little bit. Unless we make local account IDs alias to the same account as sibling parachain account IDs, we're going to still end up with two different like account IDs. We're going to have like, if I wanted to, I don't know, send a transact on that chain and have the transaction be using the same account or be authorizing things on the same account ID as what this XCM is working with, that's still not it's still not going to work, because there'll be two, as we covered earlier, that describe family is going to result in a different description for a local account ID than one for a foreign parachain's account ID. Yeah, unless we make it the same, unless we disregard whether it's local or foreign. But the fact that we have describe family in there means that we're not disregarding it, and there are good reasons for doing that, right? Maybe there's code, maybe the place it's coming from is dodgy chain, and we don't want dodgy chain to be able to empty everybody's account. Dodgy chain would literally, in that case, be able to empty any account ID on that chain. It would just pretend that it's sending a message from that user, yeah, and on itself, and then that would then map to that user's account ID, and then it would just withdraw asset. Very, very simple attack, yeah? So we generally don't want to do that, but what we might consider doing is having a whitelist of foreign foreign parachains whose account IDs are able to basically, if you have an origin that's of the form of / trusted parachain / account ID, what we might have is a way of converting that origin into just account ID. And what that says is, if the origin is an account ID that's located on a parachain that I trust, then that account ID is able to be used as a local account ID. Yeah, but I must trust it. The instruction for doing this, convert origin, already exists, right? I think actually it's called alias origin, but something like that. And you can configure it. You can just write code and configure it to do what you want. So you can configure it to match on on a / parachains that you trust / account IDs, and then have it convert into just a account ID / account ID. Yeah. And this would solve that issue. But of course, and the question is, do I really trust it? Do I really want the case that if Moonbeam gets governance attacked, it can empty the assets on everybody's account? It's a very questionable trust decision. You're basically trusting Moonbeam to not get attacked. And if it does get attacked, you're screwed. So you've got to be very careful. But the possibility exists. Okay, so we're telling it we want to deposit a reserve asset, all of them, onto this destination, the DEX parachain. And when it gets into the DEX parachain, what's going to happen is it's going to say, hey, right, I'm the reserve chain. You guys need to, the DEX, you need to mint some wrapped asset. Here's how much. Yeah? And they trust us to tell them the right amount because we are the reserve chain. So that's the trust relationship there. And then that's it from me, clear origin. And then next up is this stuff. Buy execution. I would like to buy execution with that now wrapped asset that's sitting in the holding register. I'm going to exchange something with it, with what's left. And then I'm going to deposit what I've now got from the exchange into some beneficiary account locally. So now what this does is it says, I'm sending some assets to the DEX chain, paying for some execution, and I'm going to leave the exchanged assets in an account local on the DEX chain. I can name the account, but it's still on the DEX chain. Yeah. And that's not quite what we're after. We want the assets back, right? The new assets, the exchanged assets. So yeah, we've sent the tokens, we made the swap. How do we get them back? So the specific thing, we're initiating the reserve withdrawal on the reserve chain, withdrawing assets, essentially removing them from the holding account, and then sending the, okay, right. So this code now executes on the DEX chain. Okay, this is code that executes on the DEX chain. We are no longer on the reserve chain. We are pretending now for the moment that we are on the DEX chain. Furthermore, we are pretending, are we pretending? Yes, we are pretending that we have assets in the holding register, wrapped assets. In Polkadot terminology, we call them reserve assets or reserve-backed assets, but wrapped assets works well as well. So, sitting on the DEX chain, we have wrapped assets in our holding register. What this instruction is doing is it's saying, get rid of those from the holding register. I am asserting that they are wrapped assets, i.e. that there is a reserve that we know about sitting somewhere that holds the real ones at a one-to-one basis. Here is the reserve. In this case, it's the parachain that we came from, up parent down parachain. It's our originating reserve parachain, you remember. And then when you've gotten me those real assets, not the wrapped anymore, the real assets on the reserve chain, this is what I want you to do. Buy some execution and then deposit them in my account on the reserve chain. So we're getting the assets back again, yeah? So this takes them from the holding register on the DEX chain all the way to an account on the reserve chain. So, yep, happy with that? Good. So we're going to put it all together, and this is our final code. So let's run through it. We are on the reserve chain. We withdraw some assets, the real assets, buy some execution, deposit reserve assets, so we deposit a wrapped asset, yeah, into this destination, the DEX. And once they're deposited, we want this code to run, because they're only going to be sitting in the holding register. If no code runs, holding register vanishes, and we've lost the assets. So we want to make sure this code runs. We're going to buy some execution. We're going to exchange the asset, presumably giving whatever's left from the fees into something, into what we want. And then, with the assets now in the holding register, we're going to initiate a reserve withdrawal. Yeah, so we're withdrawing the wrapped assets. If it makes sense to you, if it makes more sense to you, just exchange the word reserve for wrapped. Initiate wrapped withdrawal. Yeah? We're withdrawing the wrapped assets, and we want to unwrap them. Indeed, this in that terminology would just be called unwrap assets. Everything. We want to do it with everything, and our reserve, so the place where the real assets are stored, is back on our originating parachain. Then we have the XCM code that we want to run when once these things are unwrapped and we're running on that chain. Well, what we want to do is buy some execution and then deposit the asset into our beneficiary account. And this is the code that you need to run in order to use a DEX chain to exchange some assets on your chain, the reserve chain. Now, this is making a few assumptions. One of them is that we are recognized as the reserve chain for both the sending and the receiving asset. Yeah, might not be the case. In Asset Hub's case, it usually is. And this is probably code, more or less this code will be running on Asset Hub to do exchanges with the with Hydra DX or the DEX. It's also assuming that we can pay for fees with whatever asset is coming back, and then separately for fees with whatever asset is going there. Some chains support this, many don't. Right? It's possible to support it. It's quite easy to support it these days. Fee payment in arbitrary assets, but it's you know, it's not. One shouldn't expect it necessarily. And it's assuming that we don't need to go through a third-party reserve. Sort of the same thing that we can imagine being the reserve for one of these assets, but it's quite likely that at least for the other asset, we're going to need to go through a third-party reserve like Asset Hub. It's also assuming that we don't need any special error handling. Basically that we are able to look at the chain state and make this certain to execute correctly. Now, this is generally possible, but it takes a bit of logic to, for example, know exactly what fees you need to be paying. Now, in the worst case, suppose we withdraw our asset, we buy some execution, deposit the reserve asset, and we get to here with this code execution running, and then it turns out these fees are not enough. What happens? Well, whatever's in the holding register, assuming that we've got something that's recognized as being valuable in the holding register, this would become trapped in the asset trap. And we'd then need to send a message from this chain to claim those assets back. Yeah, that's possible. But that would be our only fallback. Yeah. That's our only way of managing something if this went wrong. So generally speaking, it's really important to be conservative and accurate when determining the fees. Yeah.
Yeah, so when, for example, the fees kind of like gas out in the second instruction, but we have this instruction call, like you put any instruction to be called when the XCM instructions, the main ones, finish to execute. You know, it's called, I don't know the name of index something, like I forgot the name of it. Like you put it like at last, like if each of the instructions already finished executing, you execute this at last, like finishing. What? Appendix, yeah,
Yeah, sure.
Yeah, appendix, yeah. So can appendix run at that point, or because the fees are, or like the weight is already consumed, or like does appendix also run even if the weight is already consumed? That's my question.
Yeah, that's a fair point. So appendix, the appendix mechanism is just a low-level part of the XCVM. If there is anything in the appendix, it will run if there is an error. Now, the way that we protect this is to say, well, what happens if by execution fails? Then it just goes to the appendix and we can do whatever we want in there, right? And then it's a DOS attack again. Well, for that to happen, there has to be something in the appendix. And as I mentioned earlier, the barrier checks to make sure that the only instructions before by execution are the origin mutators and something that can withdraw those assets. If there is a set appendix before, it will fail, like the barrier won't pass. Because for exactly this reason, You could attack it. You could put something in the appendix, and then by execution fails, and then it runs the appendix, and then you can do whatever you want in the appendix. So the barrier will ban those programs that try to do that. The barrier is very, very conservative. All it does is say, right, you can mutate the origin because I know that this is cheap, and you can withdraw some assets because I know that you need those assets to be able to pay, and then by execution, effectively must succeed. Now, suppose by execution fails, there's no appendix or error handler, so there's no way of executing any further code, but asset trap will kick in anyway because it's just part of the XCVM. There isn't an instruction associated with it. And so if you have withdrawn assets, but you're unable to buy execution with them for whatever reason, maybe you guess the gas to be too low, maybe you guess the fees to be too low, then that asset trap will kick in and those assets will be held under the origin that the message is incoming from. If you have descended origin first, into, for example, your account ID origin or whatever, it will be that origin that the assets are held under. Now, if you're going to be super conservative, even that isn't so, yeah. One way of like reducing the chance that by execution will fail is just by giving unlimited weight and all of the fee, all of what's in holding as the fees, and it will just, you know, it will pay everything if it needs to, right? You generally don't want to do that, but you could reasonably give unlimited weight because it's unlikely that the chain's weight calculation is going to be very, very much off. And then for fees, you would probably just give something that is conservative but not crazy. And the only issue then is initiate reserve withdrawal, because it sends a new message, has its own fee structure. We can't associate a specific amount of weight with it and use the regular weight-based fees because it can have fairly arbitrary weight. This might be something that we revisit in the future, but for now, initiate reserve withdraw takes fees in a separate fashion, and it will be based on, amongst other things, how full the message queues are. Otherwise, someone could just send lots and lots and lots of messages and fill up the queues. Yeah, we got to, for this, you're going to have to sort of inspect the chain beforehand and work out what the likely cost will be to use the initiate reserve withdraw function. Again, realistically, your message is going to execute reasonably quickly within a few blocks usually, and therefore your UI can probably just make the fees something conservative. Just look at, like, you know, just do a daily thing or whatever, and look at how much fees are really tend to be needed, and just add a little bit on, and that's probably going to be fine in practice. But if we're doing it properly, you would look at the destination chain, you would look at its message queue site capacity, you would look at a couple of the other bits as well. I think there's a fee multiplier, and then you would maybe work out the maximum, the worst possible case of how it could change before your message arrives and gets executed, change the fee accordingly, and then use that. And that would be a correct, precise way of doing fee calculation. That code is stuff that we are working on at the moment, so that, you know, you would find a utility function that basically would do this off-chain. Doing it on-chain will require a bit more effort, simply because you need to basically get state proofs. Right, you need to have some oracleization function that gets the state from the destination chain, and then interprets it for you and gives you the feedback. It's better to handle it off chain for the moment. So basically, put this logic in the UI and have the UI go to the inspect the destination chain. Or if you want to cowboy it, just put something big in and it'll probably work. And if it doesn't work, be ready to use the asset trap. Be ready to have a message to go that claims the asset back for the user. Okay. Right, that was a long one, but you should be, I think, a bit better prepared to understand the sorts of attacks and security issues that might come about from, particularly from origin, questionable origins and questionable sovereign account conversion. You've seen now one of the ways that you're going to have your frame configuration be able to be adapted for an XCVM configuration, so it can be used by the XCVM. And you've got a reasonable idea now about a particular use case and seen the sort of code that you have to write in order to make two chains be able to use each other. Good. That's everything for this one. Next, we will be looking at specific configurations within Polkadot. I think we're actually going to look at the Rococo testnet XCM configuration and start. I'll go through that with you and you can get a feel for what a real chains configuration looks like. Good. Let's take 15 minutes back at 11 to start that next one.